Hi guys, this is Apeksha from Simply Learn, and today we are going to talk about the two types of machine learning, supervised and unsupervised learning, their types and applications. But before we talk about them, let's quickly understand what is machine learning. These days, applications use artificial intelligence in machine learning to optimize speech recognition. I usually ask Siri things I want to know, like, "Hey Siri, how far is the nearest subway?" So whenever we ask something to Siri, a powerful speech recognition kicks off and converts the audio into its corresponding textual form, which is then sent to the Apple servers for further processing. Then, neural language processing algorithms are run to understand the user's intent. And then finally, Siri tells you the answer. Well, this is what machine learning is all about. Making the machines learn and act like humans by feeding them with data and information without being explicitly programmed. As we saw in the previous example, when the data comes in, machines immediately starts analyzing the data and eventually gets trained on it and learns it. Now, when a new data point comes in, machine accurately makes prediction and decisions based on the past data. Now that you know what is machine learning, let's talk about supervised and unsupervised learning. Supervised learning, as the name suggests, works under supervision, that is, it's a learning in which machine is trained with data which is well labeled, and then it predicts with the help of the labeled dataset. But what is a labeled dataset? Data for which you already know the target answer is called a labeled data. Like I show you an image and tell you that it's a dog, then it's a labeled data. While if I show you an image without telling you what exactly it is, then it's an unlabeled data. Now let's say we have images which are labeled as spoon or knife. We then feed it to the machine which analyzes and learns the association of these images with its labels based on its features such as shape, size, sharpness, etc. Now, when a new image is fed to the machine without any label, with the help of the past data, the machine is able to predict accurately and tell that it's a spoon. Hence, in supervised machine learning, the algorithm teaches the model to learn from the labeled example that we provide. So supervised learning can be further divided into classification and regression. It is a classification problem when the output variable is categorical, such as red or blue, disease or no disease, male or female, whereas it's a regression problem when the output variable is a real or continuous value. For example, salary based on work experience, weight based on height, so it creates a predictive model showing trends and data. So now if I say, will I get a salary raise or not? That's classification. But if I say, how much salary raise will I get? That is regression. Now let's understand classification with the help of an example. In order to predict whether an email is a spam or not, first we need to teach our machine what a spam mail looks like. This is done based on a lot of spam filters, like firstly reviewing the content of the email, then review the email header and search if it contains any falsified information. This is done based on some keywords like free, lottery, price claim, etc. Then general blacklist filters to stop emails that come from already blacklisted known spammers, and etc. So all these filters scores the email which is known as spam score. The lower the total spam score of the email, it is more likely that the email will land in subscribers' inboxes. So based on the content, labels, and spam score of the new incoming mail, the algorithm decides whether it should land in inbox or the spam folder. Now let's quickly understand regression. So let's say we have two variables, that is temperature and humidity, where temperature is the independent variable and humidity is the dependent variable, such that as the temperature increases, humidity decreases. Hence, they are correlated. When we feed this data to a regression model, it will understand the relationship between these two variables and how one variable depends on the other. After the machine is trained, it can easily predict the humidity based on the given temperature. Well, that was about regression. Now, let's see some real-life applications where supervised learning is used. So supervised learning is used in risk assessment to assess risk in financial services or in insurance domain to minimize the risk portfolio of the companies. Image classification. Facebook recognizes your friend in a picture from an album of tagged photos. So image classification is one of the key use cases of demonstrating supervised machine learning algorithms. Obviously, a lot more goes into all these, like convolutional neural networks, etc. Fraud detection. whether the transactions made by the user are authentic or not, and visual recognition, the ability of a machine learning model to identify objects, places, people, and actions in images. Now, let's quickly talk about unsupervised learning. In unsupervised learning, there is no supervision. That is, no training will be given to the machine, allowing it to act on the data which is not labeled. Hence, machine tries to identify patterns and give the response. Let's take a similar example as before, but this time we do not tell the machine whether it's a spoon or a knife. The machine identifies patterns from the given set and groups them based on their patterns, similarities, etc. Again, unsupervised learning can be further grouped into clustering and association. Clustering is basically where the machine forms groups based on the behavior of the data. Secondly, association. It is a rule-based machine learning to discover interesting relation between variables in large datasets. For example, which customer made similar product purchases is clustering, whereas association is which products were purchased together. Now, let's understand clustering with the help of an example. To reduce their churn rate, a telecom company studies the behavior of the customers based on average call duration and internet usage and observes that while some customers' call duration is quite high, others have heavy internet usage. The customers are grouped based on their observed behavior and a strategy is adopted to minimize churn rate and maximize profit via suitable promotions and campaigns. As you can see in the chart on the right hand side, customers in Group A uses more data and also have high call duration. Group B customers are heavy internet users, while Group C customers have high call duration. So Group B will be given more data benefit plans, while Group C will be given cheaper call rates to buy their loyalty. So this was the example of clustering. Now let's understand association with another example. Let's say customer 1 goes to a supermarket and buys these products, say bread, milk, fruits, wheat. Then customer 2 goes and buys bread, milk, rice and butter. Now, when customer 3 goes and buys bread, it is highly likely that he will also buy milk. Hence, relationship is established based on customer behavior and recommendations are made. Now, let's look at some real-life applications of unsupervised learning. Market basket analysis is a machine learning model based on the algorithm that if you buy a certain group of items, you are less or more likely to buy another group of items. Semantic clustering. Semantically similar words share similar contexts. People post their queries on websites in their own ways. Semantic clustering groups all responses in a cluster with same meaning to ensure that the customer finds the information they want quickly and easily. It plays an important role in information retrieval, good browsing experience and comprehension. Delivery store optimization. Machine learning models are used to predict the demand and keep up with the supply. Also, to open stores where demand is more and optimizing routes for more efficient deliveries according to past data and behavior. We can also use unsupervised machine learning models to identify accident-prone areas based on the intensity of those accidents and the area in order to introduce safety measures. By now, I hope you've understood supervised and unsupervised learning. For a quick recap, let's see a few differences between the two. The most fundamental difference is that supervised learning uses known and labeled data, and unsupervised learning uses unlabeled data as their input. Secondly, supervised learning follows a feedback mechanism, while unsupervised learning does not. Also, the most commonly used algorithms in supervised learning are decision tree, logistic regression, support vector machine, etc. And in unsupervised learning, they're k-means clustering, hierarchical clustering, a priori algorithm, and many more. So that's all for supervised and unsupervised learning. Keep watching this space for more such videos. You can also visit www.simplylearn.com or comment below if you have any questions. Thank you and have a great day.
Hi there, if you like this video, subscribe to the Simply Learn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.